Hello everyone. Welcome back to my channel. I hope everyone is doing great. My name is Raviteja. Let's solve today's Leetcode problem 762. Prime number of set bits in a binary representation. Given two integers left and right, return the count of numbers in the inclusive range of left to right having a prime number of set bits in their binary representation. Recall that the number of set bits an integer has is the number of ones present in when written in its binary. Okay, for example 21 written in binary is 10101, which has 3 ones in it, so total number of set bits we have is 3. Okay, now let's look at the first example. From 6 to 10, okay, from 6 to 10, if you see all its binary representations, 6 has 2 ones, so it has two set bits, and 2 is a prime number, so this will be contributing to our answer. 7 contains 3 ones, 3 is a 3 set bits, right? So 3 is a prime number, so this also contributes to our answer. 8 has 1 okay, but 1 is not a prime number, right? 9 has 2 ones, right? So 2 is a prime number, so this also contributes to our answer. And 10 has 2 ones, and this will also contribute to our answer. Okay, so one idea that comes into my mind is we'll loop from left to right, and for every number we will count the number of set bits it has, and let's say the number of set bits for a given number is x. Okay, now we have to check whether x is a prime number or not. Okay, how do we check whether x is a prime number or not? Prime number has only two divisors, right? Either 1 or itself. Okay, let's say 2, let's say 3 as an example. 3 has only two divisors 1 and 3, right? No other number can divide 3. Okay, so how can we identify a particular number is a prime or not? Okay, you can basically start from 2 and go all the way to the given number x and check if none of the numbers is dividing the x, then it's a prime number. Okay, that is one approach. The other approach is go all the way up to the square root of x and check whether these numbers are dividing x or not. Okay, this is another approach. So do we really have to check for every number whether it's a prime or not? Okay, so let's look at the constraint first. Okay, if you look at the constraints, as you can see, the rightmost number is of 10 power 6. Okay, so if you convert the 10 power 6 in terms of 2 to the powers, okay, 2 powers, this will be approximately equal to 2 to the power of 20. Okay, that means at max we can have 20 set bits. Okay, so since we have at max 20 set bits, that means we have set bits from 1 to 20. So now we have to identify what all prime numbers do we have from 1 to 20, right? So from 1 to 20 we have only limited number of prime numbers, okay, such as 2, 3, 5, 7, 11, 13 and 17 and 19. Okay, these are the prime numbers which are less than 20. Okay, now if you basically count the set bits from left to right, okay, for given this range, okay, so the number of set bits will always be less than 20. Okay, so we can straight away count the number of set bits for a given number in the range and then check whether the number is prime or not. If it's a prime, then include it as part of your answer, or else don't include it. Okay, so as you all know, to identify the total number of set bits, right, it is pretty simple. Okay, we basically check for a given number the least significant bit, is it set or not. If it is set, then we'll increment our counter and then we'll left shift our number. Okay, and we'll do this operation as long as our number is greater than 0. This way we can count all the number of set bits. You can write this algorithm, or you can use inbuilt functions like integer dot count bits, that also you can use, but I highly recommend you to implement it so that in interview it will be helpful for you. Okay, now I'm just going from left all the way up to the right and then checking whether the set bits in the given number is prime or not. Okay, if you submit this, all the test cases will be passed and it will be a pretty efficient solution. If you like the explanation, hit the like button and hit the subscribe button. Also share your valuable feedback in the comment section. Thank you.